They're usually okay.
I want a Brett tech talk.
Yeah, let's get Brett up there. Brett on the whiteboard. Brett on the whiteboard. Yeah.
Yeah. Awesome. Thank you. Whenever you're ready. Is it recording?
Yep.
I'll have fun editing that. Okay, cool. All right, so, hi.
Hey.
It's been a while since I did any kind of a tech talk or anything in front of the students, so there are going to be a couple faces out there that I am not as familiar with, and I apologize in advance if I don't get your name right. We've grown fast enough that that's happened now, where there are students out on the floor, and I'm like, don't quite remember that person's name. So I'm embarrassed in advance for when that happens, but if it happens, there you go. I don't have a real particular agenda today. There are things I could talk about, but what I'm more interested in finding is just opening up the floor to a Q&A from you guys. Any sort of like technical thing you wanted to ask about any subjects in the school, or what it's like out there when you're looking for a job, or what it's like when you get a job, or any particular challenges you think might come down the pike that you want advice on. I'm an open book and I'll talk to you about anything. So anybody who wants to put themselves on the spot and ask me anything, it's totally fine. Otherwise I can just start yammering about something. Anybody have like an area of interest that is kind of curious about, technology-wise?
There is. I just have to think for a second.
It's totally fine.
Yeah.
I said I'm putting everybody on the spot, so it's totally good. All right, well then what I'm going to do to just get things going is tell you about a project I've been working on that you guys are going to see pretty soon. How many of you have done any kind of work on Linux at all? Who here does not know what Linux is? It's okay to say yes. Okay. I didn't come up through the Unix or Linux ranks at all. I mean, I grew up on IBM PC clones in the early 80s. And before that, it was a Commodore 64, for those of you who want to research ancient history. And so the thing I've been very familiar with all the time is PCs. In other words, the Windows operating system, right? Back when it was MS-DOS, and all the way up through when it actually got a graphical user interface, and then through Windows 7. 8 shouldn't exist, it's an abomination, and I'll be using 10 pretty soon, right? But over here on the Linux side, in other words, Unix, I really hadn't done much until about 1.5 years, 2 years ago when I started digging into Python. So if it'll prove helpful at all, I want to share a little bit about some of the challenges I found in delving into that world, because it's no longer just a world where you can be only a Windows developer or only a Linux, Unix developer. The best guys out there have skills across the board in a lot of different ranges. So a couple things to know. Unix was, been around since what, like 1970 or something? It's been around for a long time. And it's almost always meant to be used by the command line interface. You know, you get that little symbol, and then you put in your command like dir, and it lists out all the folders in the directory. Dir is directory, right? And you can issue lots of commands from that line. It didn't have a graphical user interface. And so when you're out there dealing with guys that are Linux or Unix guys, most commonly they're used to operating from here, and they can memorize, dozens, if not hundreds of different commands, and all the different options you need to put on to those commands to be able to do things like copy files one place to another, start up different programs, end programs, create virtual environments on their machine. You can do it all from right here. And for those of us that grew up on the internet and who grew up with a graphical user interface, that can be a pretty difficult transition. And it's been challenging because you have to visualize everything inside your head, or constantly make use of commands to over and over again print out what your directory structure is and remember where you are and what kind of environment you're in. So it's just one thing that if you're going to start diving into Linux and Unix, go back and brush up on your command line interface skills and how it is that you navigate up and down directory trees and that sort of thing. Who here does not know what I meant by those last couple of comments? Navigating up and down directory trees and all that. Okay, good, cool. So this is something that, because Windows was so successful, people move away from. But if you remember down here on your little start button in Windows, you can actually pop it open, and you can, if you search down inside accessories, you can find a thing called Windows Explorer. Anybody ever use that? Okay, now you used it all the time without knowing that's what you're using, because also down here is a little icon of a manila folder. And you click on that all the time to find stuff. What you're actually doing is you're activating a program called Windows Explorer, right? And Windows Explorer was one of the first big developments in graphical user interfaces. In fact, it's something that Steve Jobs saw when he went into the Palo Alto research compound. Xerox, we've all heard of, because it's turned into an actual verb, right? Xerox is for me. They were big into office equipment, but not really into computers. When they decided to research computers, they got really smart about it. They were used to really, really good research and development staff. And they turned their research and development staff over to researching the interface between man and machine. And they came up with things like, the mouse. They created that. Or a graphical user interface where all the files on a program, on a computer, are represented by symbols representing a folder and then the files in them, that sort of thing, right? They came up with all this and more, and both Jobs and Bill Gates actually saw this stuff because it's down there in the Bay Area, and much of it was used by Jobs on his first Mac computer back in the 80s, right? So the point is that when you're going to go from, there's these two different paradigms. And this is something that actually a software developer should be able to think with. On the one side, you have simply files on a computer. So if you can think of, like, here's your big computer, you have all these disks in it, right? Your hard drive, and you're storing lots of files in there, right? And you've got files here, here, and here, and here, and here, and here. The fact is, any one file might have some sort of a hierarchical relationship to another. In your mind, when you, as the person who's organizing where you're putting your files, when you were thinking about it, you're thinking to yourself, well, here I have, for example, my school area, or folder, or the term they used was directory. Okay? But under here, I'm going to put, well, I'm going to have some files, a whole separate thing called grades, and then one called students. These are also directories. Now, you're visualizing all this in your head. There was no way to represent this in the computer at all, except by defining relationships, saying this is the parent, this is a child, and this is a child. They could be anywhere they wanted to be in terms of efficient use of your disk. They'll be wherever they are when they're stored. And so this relationship was conceived in the developer's mind when he laid down file structures on a computer. And that's why you find some of these old school guys, or guys that have worked on these, like Python, where they have to use the command line interface and keep all this stuff in their head. They're very good at grasping these intellectual concepts and spatial relationships and hierarchical relationships and things, where a person who grew up in the modern web-based interface world sometimes isn't. Can't think of those because he doesn't have to, because it's right in front of him. You can see it at a glance how everything's related. So to go back, you have this hierarchical, well, what a funny word, right? Relationship that you've defined, where you have a parent directory, and then you might have subdirectories under it, and you can put files inside those directories, or this parent directory can also have files. Everybody getting that so far? Okay? So this, again, was all just conceived of in the developer's mind, and when he would save things onto disk, he would define where they were, like conceptually, or relationship-wise, or logically. It wouldn't define where they were physically in your storage medium. So along comes the graphical user interface, and they say, oh, well, okay, here's this relationship you've defined. We've got to have a better way for people to conceive of this, because we're trying to open up computers to the masses, specifically to office workers, people that worked in modern business. And that's where the actual paradigm of, oh, well, let's have a manila folder represent a directory. And inside here, you'll have a little symbol that looks like a text document to represent a file. That's exactly where they came from, but all they had was this to begin with. So that is the beginnings of the graphical user interface. And it took on, it went everywhere, as you know, because you guys use them all the time. Now you have these icons, these symbols that represent lots of different things. So to get back to what I was talking about, though, does that help, by the way? Does that clarify that for you? Okay. Back when it was this way, when you'd have files saved all over on your computer, if you wanted to do things with files, again, all you'd have is that command line interface where you'd basically like change your directory from here down to here because you wanted to access this file. And so you'd have commands. What you're doing is changing the attention of the computer, the focus of your computer. Where am I looking right now in my file structure? When you're working in Unix and Linux, you do this all the time. You just up and down all these directory trees, and you either have to have them written out somewhere or conceive of them in your mind. And so it's just a bit of a different challenge. That's all. It's just something to get used to, okay? And it is something that you'll probably encounter at one point or another in your career as a developer. Even on the Windows side, sometimes, every once in a while, you have to do this, but it's very rare because they're all about the GUI. They're all about the graphical user interface in Windows. Over in the Linux world, they're really not so much. So I'm sitting there using Linux, and Linux, of course, is just an operating system like any other, okay? How many people here are only within the first 1 or 2 courses of the boot camp? Okay, good. All right, good. So remember that you have, your central processing unit, and you have connections for input and output. Well, this is your machine. This is your computer, right? But you need an operating system to run this, and it handles all those baseline functions like directing input and output, managing your memory, all that kind of stuff. And there's 3 different flavors that are popular nowadays. We've all heard of them: Windows and Linux or Unix, and OS 10, Mac OS 10, okay? Unless you're not running OS 10 and you're running 9, in which case, come to present time, like what are you doing, So here's all these operating systems. You guys are being taught primarily on the Windows operating system. It's still the most popular out there by a long shot. But in the web development world, a lot of stuff is being run on Linux. More and more and more and more. Now, about 5 years ago, you could be a Windows developer and not give a rip about this stuff over here because it was infrastructure people that handled this. It was the guys that ran operations, the guys that ran these big web servers or application servers where you'd store your web pages or your applications, and people would make requests in there to get stuff from them. Those could have been on a big Unix or Linux machine, and you wouldn't have had to deal with this as a developer. You're the one that made the website that got saved there, but that was as far as it went. You're the one that made the program or application that got installed on an application server, but that was as far as it went. With the advent of DevOps, that changed. DevOps means development/operations. And what you're talking about, for those of you who aren't that far into the program, is development is the environment in which you actually produce code. This is what you guys are working in all the time. You're sitting there and you have your personal computer, whether it's a laptop or an actual physical desktop machine, and on it you might actually have the things you need to develop. You've got probably SQL Server or something else like it so you can make databases. You have all the code, the integrated development environment you need or whatever to write maybe your C# code or whatever, right? You've got all of this on your machine. And then you write all your code on there, and then you need to put it somewhere along with the other developers who are working on the project where it all gets put together and run, executed. That would be your development environment. Very typically, this is something like a Windows Server machine. Who here has heard of Windows Server? Okay, so Windows Server is just an operating system, just like the Windows that you have on your computer. All it is an operating system from Microsoft that you install on a physical machine, just like this up here, but it's optimized to actually host web pages and applications. Your computers are not optimized for that at all. You can do it to a certain extent, but let's say that you had 1,000 concurrent requests to a web page that you had on your computer right there. It's not going to handle that really well. With that one teeny little central processing unit and that one tiny little, you think you have a lot of memory at 256 gigs, it's not going to handle that at all. You have 1,000 people trying to get instant copies of the same web page. That machine's toast. So you have these giant machines with lots and lots of memory, lots of central processing units that it can handle thousands and thousands of requests. The operating system they run is Windows Server a lot of the time. There's lots of others, but that's one that you will work on a lot. So you have your development environment, which is a big physical machine running Windows Server, and on here you have a web server. It'll serve up web pages. You can have an application server. It'll serve up applications, and you'll learn all about this when you get on the job, right? But the point is that this is optimized for development. It's optimized for what you guys do. It's not set up for the end user of the program at all. So for example, you might have lots of utilities on here that you can use to look into the back end of your code and see where it's breaking, if it's breaking. Doesn't matter, you guys write perfect code every time, I know, right? But if you peek into the back of things, it's an environment that's perfect for what you do. Well, now you get this, let's say you get your application, you and 5 other developers are working on something, you get your application to the point where you're like, okay, it's ready for testing. You don't want it to be tested in this environment. One, there might be things you did here that are totally unlike what's going to be like in the real world, and it seems like it's working perfectly, but it's only working perfectly in your environment. And then you get it in the real world into the operations environment, and it breaks really badly because of some setup you had over here in your development environment that isn't real world at all. So what do? Well, you set up a whole other environment called software quality assurance, or QA, it's called quite commonly. Now, what you're trying to do here is make this as much like the real world as possible. So if in the real world, your company is going to deploy your web application on a very, very big web server, you try to get the exact same hardware, the exact same software that's already on there. You're trying to replicate the real world. And then your quality assurance testers go in and just bang the heck out of it. Well, they're probably a little more organized than that. They have a test plan, but they're testing this in as close to real world conditions as they can get. Now, let's say it passes there, right? It met every test they could throw at it. It meets the technical specifications you had for the program, and they also thought of some really cool things that you never would have thought of as a developer. They kicked it back to you, you fixed it, you put it back. They said, okay, good, you fixed that. Now you're ready for one of 2 different places for it to go. It could go over to what's called user acceptance testing. And this isn't always used in every development, every development path, but it's quite common. And this is a sort of like isolated version of the real world where it isn't quality assurance technicians, it isn't technology guys that are in there banging on it, it's real users. So again, it's meant to replicate the real world. What's the deployment environment for this application? But now you're having users bang their heads against it and see if they can break it and that sort of thing. And users will do the most god-awful things to your program that you never thought they would ever do, and they'll break it. So then it goes back to you, you fix it, you quality assurance, make sure you fixed it, and then it goes back to the users, you see, all the way through. And then finally, after the users say, om-som-bom-de-dom, it's all good, we're ready for this to go out to the real world, then it goes to operations. So operations is wherever it's supposed to live in the real world. Now, if you're hosting all of your websites on site, that's fine. That just means they move everything over to that other big giant web server. Nowadays, it could mean that it's going to the cloud. In other words, someone somewhere, either Amazon or Microsoft or whatever, they host your web server, and they take care of all that. But it's still got to get copied over there, and you still got to be able to manage everything once it gets there. What's the point? There's at least 3, if not 4, different environments that need to be maintained. And if you have things that aren't in sync amongst these 3 to 4 environments, your testing and development efforts are completely wasted because you're developing against what's not going to be there in the real world, for example. Or you're doing QA against what's not going to be there in the real world. If you have any problems with these, like let's say you're using a database and it stores transactions like sales history for your clients, and the version of that database you're using in development has been severely truncated and is quite small, and some developer thought he'd make it just because he's got 3 or 4 variations of all the things we're going to see. It's enough for us to develop the application on, but it's got 500 records in it. And in the real world, there's 30,000 records in it, or 1 million, or 10 million. Now, what works here in development, the first time it hits what's supposed to actually emulate the real world, where there's 500,000 records in your database, your application tanks. It dies because you weren't developing against the real world. So you can see that managing that whole set of environments is a complex activity. The tools that are used to do that, to make sure that all these environments stay in sync, they're very often administered and run on Unix or Linux machines. They have these machines that can connect to all your environments, and they'll run certain pre-programmed scripts regularly to make sure, oh, okay, the database has been kept in sync. Okay, good. All right, we had an operating system upgrade. Okay, we upgraded this one. Did we upgrade that one? Oh, we didn't. Oh, we better do that, right? They manage all that process. It is no longer just the guys in operations who are responsible for that. Modern development shops expect you as a developer to be able to run that process, or to take part in it at least. Now, they might be very nice, and they might give you some things called DevOps tools. Some of those popular ones out there you learn about on the program are from companies like Puppet or Chef. They've made their business about creating really good tools to help you manage this, but you're still going to have to be able to operate on a Unix machine, configuring all these things and making them run. So, sorry, I'm covering a lot of ground, but it's neat stuff, right? The point is that a modern developer cannot pigeonhole himself into one area. Oh, I just know SQL Server programming. I can just deal with databases. That's all I do. Okay, you're toast. In 3 or 4 years, you're not going to have a job. Or I'm just a Windows software developer. I just deal for the Microsoft .NET framework, and I build applications for that, and that's all. Sorry, I got a guy over here that can do that and can manage all this back-end stuff. So when we're short-handed, I can throw him over there, and he can actually get the job done. I'm not going to hire you. I'm going to hire that guy, right? So that's some real-world stuff. That was a lot of talking, wasn't it? Okay, good. Questions about my tremendous amount of outflow here?
What's the best version of Linux for a new developer to learn on?
Ubuntu. I'm gonna write that. U-B-U-N-T-U. I think version 14 is what we're at right now. Now, what's cool about learning this stuff is it's totally free. Like the whole Linux, Unix world, they're all about don't pay for anything, thank you very much, right? And so you can go and get a free trial account on, say, Azure, A-Z-U-R-E. Who does not know what Azure is? It's totally okay if you don't. Okay. Azure is a product from Microsoft. Basically, it's everything you could do on actual physical machines, computers and everything, in the cloud. And all the cloud means is that the machines are somewhere else. They're not in your office, right? So Microsoft manages millions of separate servers, web servers, application servers, all kinds of things. And they're all in the cloud. Typically they're over in India or they're up in Redmond, Washington, or it doesn't matter where they are, you don't care. You're going to connect to them through the internet. You can get a trial account with Azure and you can create a virtual machine in the cloud that is Ubuntu, and you can do it in about 5 minutes. And all of a sudden you actually have a Linux machine. And by the way, let me explain that. Ubuntu is a flavor of Linux. The Linux operating system, it isn't like Windows, where everybody in the public world knows the 3 or 4 versions of Windows that have come out in the last 10 years. We all know that Windows XP has been around for a long time and is real popular, but no longer supported. People remember Vista, probably not that fondly. Most of us are using Windows 7. A lot of people know about Windows 8 and know that it was very poorly received. And if you're paying attention to the technology news, you know that Windows 10 is coming out in a few months, right? We know all those. Those are the flavors of Windows that are available to you and me, right? In the Unix world, man, there's dozens upon dozens upon dozens of different variations on this operating system. I personally don't like that. I like to know what I'm dealing with so I can write software against a known operating system. But you know what? You don't need to do that anymore. You can write software that doesn't care what operating system is down below, because most of what it does is up there in the browser, in your HTML and CSS. You don't have to be concerned as much anymore. It's a pretty cool thing. The point is that there's lots of different versions of this. There's some things from a company called Red Hat. There's Ubuntu. There's other names that I don't know or care about. But you can do this for free in a virtual machine, and you can be tooling around like I did and have fun messing around with Linux or Unix in about 20 minutes tops from the time you involve signing up for Azure and doing it. So, long-winded answer to your question. Ubuntu is where I would go, right? Here's the thing is, Ubuntu is kind of cool because it does have a rudimentary graphical user interface. You're not having to deal with everything for the command line, so you can at least be in that familiar world of, I'm a Windows guy, and I need to see what my file structure looks like. Can I at least please see some folders and file icons so I can think with it? And then, yes, boom, you pop up your command line, and you do a lot of your stuff from there, but then you can see that what you did actually changes the file structure, and you go, okay, good, all right, I'm on familiar ground, if you will. There are versions of Unix that have no graphical user interface at all, and that's it. You're just dealing with the command line. So, anything else from anything? You can ask me anything you want.
So would you suggest, as a future developer, like, you know, getting a book on bash commands or something along those lines?
Bash, by the way, that term, bash is basically the way you interact with a command line interface. CLI. It's how those commands work and how you go about doing what I'm talking about. Yes. Yeah. Now here's the thing. You'll learn a little. You're going to learn a fair bit about this, and when you do Python, right? On the Python course, you actually have to set up essentially a virtual machine on your Windows machine that you have there, right? So you're going to learn a little teeny bit about how this works, not a lot, right? And you're going to learn enough that when you get out there, you're going to be fine, right? I survived for many years not knowing any of this. And the stuff I'm learning now, I'm learning because it's fun and because I know this is true about DevOps. So you'll be well enough prepared that when you get out there, you'll do fine. But yeah, this is one of the first things that I recommend as like a weekend project or something like that when you're done, or even now if you have weekends free. If you have weekends free, you're not studying enough. No, I'm kidding. It's totally fine. But yeah, I do highly recommend that, right? Any other questions? Yeah.
This program is kind of creating somewhat of a full stack developer.
Mm-hmm.
Is that right? Somewhat?
Yeah. Yeah. You're talking about the bootcamp.
Yeah.
Yeah, very overtly. We absolutely want that. Is there a question about that?
Oh, no. I was just...
No, just comment?
Yeah.
Totally fine, yeah. Yep, absolutely. Because I want you guys to be able to operate all the way up and down the stack because you don't know what kind of job you're going to get off the bat. You know? You're not going to be able to dictate, hey, I love HTML and CSS. Can I have something that's purely front end, please? And I want to get paid a ton of money for it. You might get lucky, you might not. And wherever you go, you need to be able to operate well enough that they're going to be happy to have you as a junior developer. Other questions?
Is there a cost for the Azure services? Did you sign up?
You know, there's a bunch of ways to get a certain amount of monthly credit for free. All right? We have monthly credit for free, but it gets eaten up pretty quick with some of the projects we do here. So, I think that if you... I'd have to look. They change it all the time. There's almost always a way to get free credit on Azure. And the truth of the matter is there's lots of other ways to get almost free VMs that are out there, but that's the one that I'm a Microsoft geek. And so that was the area I first went to. And I'm like, okay, I'll just spin it up in... Anybody here not know what I mean by spin it up? Okay. So you have your physical machine right here, right? This is an actual... There's a laptop, right? So who here doesn't know what a VM is, a virtual machine? Okay, good. Spinning it up means creating the virtual machine, making sure that it's configured and got everything, and then making sure it's got Python or whatever you need installed on there, and installing any other things like if you can do any database work, do I have a program to be able to read my database stuff, my SQL stuff, right? Like that's spinning it up. And so what happens when you go, for example, through Azure, you actually, it's almost like going to a menu, right? Like, well, what do I want? Well, I want a virtual machine that's going to have Linux on it. Okay, what version of Linux? Ubuntu 14. Okay, good, awesome. All right, and then how powerful is the central processing unit? Well, is it 1 core or is it 2 cores? Cores means CPUs on it, right? Or is it 4 cores? You can choose all this stuff. And how much RAM is it going to have? Oh, wow, I think it'll have, I want 200 gigabytes of RAM. I think that'll be enough. And then you go, start. And then it spins up your virtual machine. And it makes Everything's like going to the restaurant and you're ordering exactly what you want. It makes that exact machine virtually. They're not sending it to a manufacturing plant and shipping you a laptop like that. It just exists in the cloud. It exists on some much bigger machine somewhere. Part of it is turned into that exact specification you want. So when I say spin it up, I mean go through that process, hit start, and then when Azure or whatever provider tells you it's done, then you log on to it. And all of a sudden it's just like you're on a physical machine like that. That's spin it up. People, there's a bunch of slang terminology in the software development world. Spin it up gets used a lot, right? Like, and usually it means there's some service or a server of some sort that you're going to need, like a web server or whatever, that isn't turned on. You haven't started the program. So you'll say things like, can you spin up the web server? That means literally finding the executable program that when it's turned on and running will be a web server and saying, start please, and then it goes through setting itself up and allocating memory and getting ready for incoming hypertext transfer protocol requests and knowing where it's going to send them to. Okay, good, I'm ready. And then it can start receiving requests and serving up web pages. So, cool? Awesome. Anybody else? Anything at all that want to chat about? Okay, good. Awesome. All right. Totally fine. Thanks for your time. Appreciate it very much. And we're done. Thanks, Jack. Bye.
Thanks, sir.
Yep, absolutely.